measures of dispersion. At the end of this video, you should be able to define measure of dispersion. You should be able to find range, and then you should be able to find mean deviation. Now, you recall that we said that measures of central tendency is quantity, which gives us a picture of the center of the data. But measure of dispersion is a statistical measure which shows how data are dispersed or spread about the measure of central tendency. Now, the commonest measures of dispersion are range, mean deviation, interquartile range, semi-interquartile range, variance, and then standard. But throughout this video, we're going to concentrate on range and then mean deviation. Now, the range. So the range is the simplest of all the measures of dispersion. So it is the difference between the highest and the lowest values in what? In the data. So its simplicity, notwithstanding, has a major setback. It's not an efficient measure of dispersion about the measure of central tendency. So the reason being that it is possible for two different distributions to have the same range, where their variabilities about the center of the data will be different. But let's look at this example first. Find the range of the distribution. We have 5, 2, 8, 13, 21, 14, up to 2 here. Now, the first thing for us to do is to identify the highest value. So which one is the highest value here? So we have 21, okay, we have 25. So the highest one is 25. What about the lowest? We have 2, we have 1. So 2 is the lowest. Now, the difference between the between 25 and then 2 now is what? So 25 minus 23 is the range of this distribution. Now, let's quickly now look at the mean deviation. So mean deviation is a way of measuring the variability of the data about the center. Is that clear? And then, so this is to find the sum of the absolute values of the deviation of each measurement from the mean, then dividing by the number of measurements in the in the data. So if you have S1, S2 up to Sn, if you are the elements of the set of a set of the data, and then S bar denotes the mean, then the mean deviation written as MD defined by this formula. So MD is equal to summation of modulus of Si minus S bar divided by N. So if this S1 up to half frequencies F1, F2 up to Fn respectively, then the definition of the mean deviation can be modified as what? Fi modulus of Si minus S bar over summation of Fi. So class mark of the ith class interval. Now let's try to apply this this one. Let's try to apply it in this on this example. So example 1. Find the mean deviation of the following data. So we have 3, 5, 8, 11, 12, and then 21. So the first thing for us to do is to calculate mean. As you can see that this S bar denotes what? Mean. So let's quickly calculate mean. The mean of this number will be 3 plus 5 plus 8 plus 11 plus 12 plus 21, which is equal to 60. Then divided by n. So n is 1, 2, 3, 4, 5, 6. We have 6 numbers. So 60 divided by 6 is equal to 10. So 10 is the mean. Now, to now apply the Si minus, so S1 is 3. So 3 minus 10 is minus 7. So modulus of minus 7 is 7. S2 is 5. 5 minus 10 is equal to minus 5. Modulus of minus 5 is what? 5. So anywhere you get minus, this modulus will change it to plus automatically. Then don't forget that you are finding the summation, right? So we're going to add all these numbers here now. So 7 plus 5, that's 12. 12 plus 2, that's 14 plus 1, 15. 15 plus 2, that's 17. Then 17 plus 11, that's 28. So we're now going to say 28 divided by what? By 6. So mean deviation is equal to what? 28 divided by 6, which is equal to 4.67. So this is the mean deviation. Now that is for ungrouped data. But for grouped data now, The table below shows the distribution of 50 people at the birthday party. So ages in years. So we have 1 to 5, 6 to 10. So we have number of people. So this one will be frequency. So find the mean deviation of this distribution. So for us to find the mean deviation of this distribution, so we're going to find will serve as x. So the class mass will be what? 1 plus 5, which is equal to 6 divided by 2 is 3. So you now do the same thing for every for each row here. So 21 plus 25 is equal to 46 divided by 2, that's 23. 26 plus 30 is equal to what? 56 divided by 2 is equal to what? 28. So then this one now, let's now go and prepare table. So ages in years, class mark, that is this plus this divided by 2, this plus this divided by 2, this plus this divided by 2. So this is the frequency. So we're going to use an assuming. So let's pick which assuming in order to find x. Because without this x, we cannot find this column and then this column. Is that clear? So let's pick 18. So if we pick 18, the class size is what? 5. So 1, 2, 3, 4, 5. Class size is 5. So this is the frequency. So d is equal to s minus assuming. So 3 minus 18 is equal to minus 15. 8 minus 18, we said that let assuming be 18. Is that clear? Let assuming be what? Be 18. So let's see the formula for mean. So we have assuming to be 18. Class size is equal to 5. Summation of fu is equal to minus 23. So if you look here now, so to calculate u, I've shown how to calculate u, right? So u is s minus a divided by class size. So s minus a is 15. 15 divided by class size, which is 5. Minus 15 divided by 5, minus 3. Minus 10 divided by 5, minus 2. And you complete the rest. Then fu means what? F multiplied by u. So 9 multiplied by minus 3, minus 27. 4 multiplied by what? By 2 is equal to 8. Now we'll now go and use that minus 43 and then 50 to calculate mean. So to calculate mean, assuming plus c, summation of fu over summation of f. So assuming is what? 18. 18 plus 5 multiplied by minus 43 over 50. So we have 18, then 5 divided by 50, that's 10. Okay, 1 over 10. So we have 43 divided by 10, that is minus 4.3. So 18 minus 4.3 is equal to 13.7. So here is supposed to be minus. So MD now is equal to summation of modulus of f modulus of s minus bar over summation of f. So to get, we now go back. Since our mean is 13.7 now, that is what we now use to generate this column. So 13.7. So we say SI. So S1 now is 3. 3 minus 13.7 is equal to 10.7. But it's equal to minus 10.7. But because of the modulus will take care of what? Minus. It will turn everything to plus. Exactly. Even if the answer is minus, it will still be plus because of this modulus. So let's try the last one. 4 minus is it? Okay, xi. No, 28. So 28 minus 13.7 is equal to 14.3. Is that clear? Then multiply by f. So you will now be taking 9 multiplied by 10.7 is equal to 96.3. 8 multiplied by 5.7 is equal to 62.7. So 28 multiplied by 14.3 is equal to 57.2. So by the time you find the summation of this one is equal to 392.2. Is that clear? So this is what you need. Divided by 50 will now give you what? The mean deviation. So divided by 50. So mean deviation is equal to summation of f of f, which is equal to 329.2 divided by 50, which is equal to 6.584 years. So this is what? The mean deviation of the what? Of the distribution. So if this one is clear, so I would now like you to look at this the exercises here. So the first question is define measures of dispersion. So number 2, the number of goals scored by football team in 20 matches is shown in the table below. So number of goals, then number of matches. Then number 1, letter A, find the mean number of goals scored. then mean deviation of the distribution, then the range of the distribution.